Welcome to the DX Today podcast, where you get facts, not hype. Today, we are doing a really critical deep dive. We're talking about the technology that is basically remaking how enterprises use large language models, Retrieval-Augmented Generation.
Or RAG, as we should probably be calling it for this deep dive.
Exactly, RAG. Let's stick with that. It's easier to say.
It is, and it's really the essential architectural bridge. It connects the raw, often generalized intelligence of a large language model.
The foundational models, right? The ones trained on, well, basically the entire internet.
The entire internet, which is a vast but ultimately finite and public data set. RAG connects that to the specific, proprietary, and constantly changing knowledge inside an organization.
Okay, let's unpack that right away, because RAG exists to solve a really fundamental, almost existential problem for these models in a business setting. I mean, we were all blown away by what they could generate at first,
But relying on that fixed training data led to some serious trust issues.
That's it exactly. So what is the core operational problem that RAG is designed to fix for, a high-stakes business user?
Well, the fundamental problem is really a pair of critical flaws: stale knowledge and, of course, hallucination.
Okay.
So because the LLMs only know what they were trained on up to a certain date, they become instantly outdated. I mean, if you ask a model trained in 2023 about a new regulation that passed this morning, it has no idea.
It's a black box to it.
Completely. And even more dangerously, these models are built to predict the next plausible word, not to retrieve an exact fact. So they often just confidently produce incorrect, totally fabricated information.
The notorious hallucination.
That's the one.
And RAG is what grounds the response in reality.
Exactly. RAG steps in right at the moment of the query. It pulls verifiable, authoritative context from the company's own documents, its own knowledge base.
This is providing the facts on the fly.
On the fly. And this grounding, it dramatically reduces fabrication, and this is crucial, it allows the system to provide source citations. It can give you a link to the original document, the paragraph, the page.
Which makes verification simple and actually builds the trust you need to use it.
That's the whole game.
So RAG really transforms the LLM from this kind of speculative creative writing partner into a trustworthy, research-backed knowledge system. And just to be clear, this lets companies use their own private data internal reports, customer info, without the massive cost of constantly retraining the foundational model itself.
That's the core value proposition right there. It's the efficient, scalable way to bring your specialized data to these big, generalized models. It allows for rapid deployment without the huge operational lift of continuous updates.
So our mission today for you, the learner, is to move beyond that initial AI hype and get deep into the architecture. We need to understand the technical nuts and bolts that separate a proof of concept from a real production system.
And how to quantify the ROI in a way the C-suite will actually understand.
Yes. And we'll get into the advanced stuff too, like hybrid search and agentic RAG, which are frankly necessary to build reliable systems that actually pay for themselves. This is where we move from hype to hard engineering. All right, let's start where every business conversation has to start.
The money.
The bottom line, we're seeing this maturation happening in the corporate world with AI.
A shift, definitely.
The initial sort of breathless enthusiasm for AI investment, that feeling that you had to get in or you'd be left behind, that's giving way to some very hard scrutiny.
It is. It looks a lot like the classic technology adoption pattern we've seen before, with the internet boom, or even way back with the shift to electric power in factories.
That's a great comparison.
It really is. Every truly transformative technology goes through these phases. You've got the invention, then this period of massive investment, and then the inevitable plateau. That's when companies realize, okay, deploying this is easy, but actually integrating it into our workflows to get real value is incredibly hard.
And that's where we are now, past the peak euphoria, entering what you might call a phase of necessary realism.
Yes, and while this tech is arguably the most transformative of the century, transformation doesn't excuse a lack of measurable financial results.
And the numbers that are forcing executive teams to, pump the brakes and ask these pointed questions about ROI, they're frankly terrifying for anyone who just jumped on the bandwagon. What's the sobering statistic we need to start with?
Research from MIT points to a really staggering number. It suggests that 95% 95% of AI initiatives are failing to deliver their expected financial returns.
Wow. Okay, but that needs some context, right? It can't be that the tech just doesn't work.
No, and that's the critical nuance. The failure is usually not a technological flaw. The models work. The RAG system can retrieve facts. The failure is almost always strategic and executive, meaning a failure to measure tangible value correctly, a failure to actually execute the organizational and workflow changes needed. Too many companies were just, doing AI for AI's sake, instead of engineering a system with a clear, measurable path to ROI.
That is the critical distinction. If the tech works, but 95% of the projects fail, the problem is with the strategy, not the software. So let's talk about that. Let's critique the old way of measuring ROI. What's wrong with just focusing on cost savings?
Well, the old way is what you might call the factory floor model. It's very reductionist. You just measure how many hours of manual labor were eliminated, and by extension, how many fewer people you might need.
The Industrial Revolution approach.
Exactly. And that mindset is it's completely inadequate for knowledge work. The highest value workers, your analysts, your engineers, your researchers, they're not paid for just completing tasks. Their value is in the quality of their decisions, their strategic output.
So if I measure that an LLM saved a lawyer 15 minutes summarizing a document, that's a tiny, insignificant number.
Right.
But if that summary led to a crucial multi-million-dollar insight that they would have otherwise missed, I'm measuring the wrong thing entirely.
Precisely. If you only measure the eliminated tasks, you completely miss the much bigger value of reducing costly errors, of increasing decision quality, of accelerating innovation and driving new growth. This defensive cost-cutting mindset is what holds these advanced systems back from showing their full offensive impact. So to really capture the total business impact of RAG and now this move towards agentic AI, we need a new financial framework. The sources we looked at introduce a really powerful 4-part model for this.
A model that shifts the focus from just cost-cutting to building a real competitive advantage.
That's the goal.
Okay, let's break down those 4 pillars of what we're calling the agentic ROI framework. The first one is efficiency and employee productivity. But with a twist, right? We're moving beyond just measuring 5 minutes saved here and there.
Right. Yes. Efficiency is the low-hanging fruit. But the sophisticated approach means you have to stop measuring time saved on single repetitive tasks. You have to focus on automating entire end-to-end workflows.
End-to-end. So not just writing one email, but handling the whole process.
The whole process. Think about complex things like customer onboarding, which touches multiple systems, or resolving a complex tech support ticket from start to finish, or orchestrating a supply chain audit.
I think that's a really important distinction for our listener. We're not talking about saving a few seconds on a task. We're talking about the AI handling the entire interaction loop from the customer's first message, doing the RAG lookups, escalating if it needs to, and then finally closing the ticket and writing the summary.
That's the comprehensive view. And it's actually pretty easy to quantify. Let's say you have a RAG-powered system that helps your high-value employees save just 5 hours a week.
Okay, an hour a day.
An hour a day they're not spending digging through documentation. And let's say that employee costs your company, I don't know, $75 an hour in total compensation.
Well, that one metric alone gives you an annual savings of $19,500 per employee.
Per employee.
Per employee. Now, scale that across a department of 500 knowledge workers, and you've just proven $9.75 million in immediate, measurable annual savings. It moves the conversation from hand-waving to hard budget numbers.
Okay, so pillar 2, revenue generation and business growth. This is where AI stops being just a cost center and becomes a profit center. How does RAG enable that kind of offensive strategy?
RAG enables growth because it can operate at a massive scale, 204/7, with a much wider field of vision than any human team. These RAG-powered agents can analyze vast amounts of your proprietary data, market trends, customer interactions, product specs way faster than any human.
And find opportunities that a human team would just miss.
They would inevitably miss them. Quantifying this means looking at things like incremental revenue from optimizing sales streams, or an increase in the number of qualified leads, or even just measurably shortening your sales cycle. Right, like if an AI agent helps a sales rep customize a complex proposal 50% faster.
That can directly translate into closing more deals per quarter. And that's a metric you can tie directly to new annual revenue.
That completely changes the narrative. The AI isn't replacing the strategic worker. It's accelerating their capacity for high-value work. Now, the third pillar is risk mitigation. This one feels a bit harder to quantify. It's the value of a disaster that didn't happen.
It's critical, though, especially in highly regulated industries like legal, compliance, or finance. If a model hallucinates a key legal clause, or gives outdated financial advice, or misreports a patient's medical history, The cost isn't just a bad answer.
It's millions in fines. It's litigation, loss of your license, catastrophic damage to your reputation.
All of the above.
So walk us through it. How does RAG eliminate that systemic risk, and how do we put a price tag on not getting sued?
The RAG architecture, by its very design, mitigates this risk because it mandates grounding every single piece of information in a verifiable, auditable source. So to quantify it, you can measure the percentage reduction in costly errors over time. You can measure the elimination of compliance fines or the reduction in litigation exposure.
Okay.
In a high-volume financial firm, for example, preventing just one major regulatory error, which might carry a $1 million fine, can instantly pay for the entire RAG system's annual cost. It proves that factual fidelity, guaranteed by RAG, is basically a license to operate in these environments.
And that brings us to the fourth and often overlooked pillar, employee engagement and retention.
This is a massive hidden cost center in so many industries. When your highly skilled people are constantly frustrated by archaic, siloed systems, or they're forced to do repetitive, low-value admin tasks.
Which is rampant in fields like healthcare and legal.
Absolutely. They suffer burnout and they leave. So if you can empower your teams with high-quality AI tools that actually reduce that friction and help them focus on their best work, you see measurable boosts in engagement and retention.
And the financial ROI there is the reduction in hiring costs, training costs, and the knowledge you lose when experienced people walk out the door.
Exactly. It leads to a more resilient, innovative, and stable workforce.
Okay, let's ground this ROI framework in some concrete examples from the source material. We need to see these numbers in action. Let's start with healthcare, which seems like a perfect target with all its complexity and regulatory risk.
The case of CirrusMD, a virtual care company, is a perfect illustration. Their challenge was twofold: automating clinical documentation and generating personalized benefit recommendations for patients.
So a doctor might spend a ton of valuable time just reviewing chat history, trying to figure out a patient's needs.
And then cross-referencing that against dozens of constantly changing insurance plan documents to make sure the recommendation is actually covered. It's a huge time sink.
That manual process sounds like a recipe for burnout and errors. What happened when they deployed an agentic RAG system?
The results were genuinely transformative. They saw a staggering 234% increase in the number of physicians who were actually providing those critical benefits recommendations.
234%.
Yes.
Yeah.
So think about that. They didn't just save time, they fundamentally changed the scope of care their doctors were able to deliver.
Wow. That translates directly into higher quality of care, better patient outcomes.
And they measured the other side, too. They saw a 30% patient engagement rate with the AI recommended benefits, the old traditional methods. They had a baseline of maybe 2 to 5%.
So a huge jump.
A massive jump. And this was only possible because they used a medical-specific foundational model grounded by RAG on the patient's specific proprietary insurance data. That's what ensured accuracy and compliance risk mitigation in action.
That's a perfect example. It's not just a back office tool. It's a business accelerator. Okay, what about financial services? You mentioned Prudential, operating in one of the most heavily regulated environments in the world.
At Prudential, their big bottleneck wasn't creativity in marketing. It was compliance. In financial marketing, every single piece of content that faces a customer, an email, a social media post, anything, has to be rigorously checked against strict SEC and FINRA rules.
A huge manual review process.
Huge. So their custom agentic RAG system was designed to analyze customer feedback and ensure regulatory compliance at the same time during the content creation process.
So the creative team writes the copy, and the AI is instantly auditing it against a database of regulations. That must eliminate days of legal review.
Precisely. And the result was a stunning 70% increase in speed to market for their campaigns.
30%.
Imagine the competitive advantage of being able to react to a market event 70% faster than your rivals. On top of that, it gave their creative team a 40% boost in capacity because they were freed from all that repetitive, slow compliance work.
That's the definition of RAG validation in a regulated industry: speed and accuracy.
You got it.
All right, one more. Legal tech. Specifically, the super complex, high-stakes world of mergers and acquisitions due diligence. Time is literally millions of dollars there.
M&A due diligence is a nightmare of unstructured data. Law firms have to ingest and sift through thousands of highly technical documents, contracts, filings, permits. The goal is to find specific liabilities or risks, like a problematic clause buried on page 300 of a contract.
And manually, that takes a team of specialized lawyers weeks, right, and costs a fortune.
Exactly. But with RAG, they can ingest all of that unstructured data, process it into a queryable knowledge base, and let the lawyers just ask it questions conversationally.
And the outcome.
The outcome is speed and precision that was just impossible before. The RAG system can instantly flag every instance of a change of control provision, for example, with specific citations linking right back to the source document.
So it reduces due diligence time from weeks to days.
From weeks to days. It cuts legal costs for the client, it accelerates deal closing, and most importantly, it improves the accuracy and thoroughness of the review. These examples all prove the same thing. RAG is an enterprise necessity with hard, measurable metrics behind it. We're talking about a 333% ROI in some of these documented cases.
Okay, we've established the why, the massive measurable ROI. Now let's get into the how, the foundational engineering you need to make RAG actually work reliably in production. Let's start at the very beginning, right after you get the data. Chunking.
Right. Retrieval quality is fundamentally dictated by how you prepare your raw, unstructured documents. You have to split them up or chunk them. And this is where engineers face this really crucial trade-off.
A trade-off between what?
Between context preservation and retrieval precision. And if you get this wrong, the entire RAG pipeline it falls apart.
Okay, explain that trade-off for us.
Think of it like deciding how long a soundbite should be. Smaller chunks are incredibly precise. They often match a query perfectly, which is great for precision.
But they lose all the surrounding context.
Exactly. The LLM gets this tiny little snippet, but has no idea what the rest of the paragraph or the chapter header said. So it can't give a comprehensive, well-rounded answer.
And the other way around, if the chunks are too big.
If they're too big, you preserve the context beautifully. You get the whole argument, the surrounding structure, but now you've diluted the relevance. The specific little fact you're looking for gets mathematically drowned out by all the other text in that big chunk. It might not even get retrieved at all.
So the goal is to find this kind of Goldilocks zone of chunking. Not a perfect size, but the right size to make the LLM accurate. So what are the strategies here? Let's start with the baseline.
The baseline, and still the most common method, is called recursive character splitting. It's simple. You just break the text based on a structural hierarchy. You try to split on paragraphs first, then on lines, then spaces, and so on.
It's reliable for structured text, I'd imagine.
Very reliable for things like Markdown or code, but it's completely blind to the content's meaning.
Which brings us to the more sophisticated approach. Semantic chunking. This sounds like it uses the LLM's own strength understanding meaning to decide where to split.
It is a giant leap forward. Semantic chunking groups content based on topic coherence, no matter how long it is. It's a multi-step process. First, you split the document into individual sentences.
Okay.
Then you generate vector embeddings for each sentence. Finally, you compare the semantic similarity between consecutive sentences. When that similarity drops below a certain threshold, meaning the topic has changed, that's where the system splits the chunk.
And does that actually translate into better performance? Is it worth the complexity?
Absolutely, especially in texts that are messy or unstructured, like a dense legal brief or a research paper. The research suggests this method can give you up to 9% better recall in those kinds of texts.
9%. That's significant.
It is, because it guarantees that only semantically related information gets grouped together for the LLM to synthesize.
And then there's the high-cost, high-quality option, LLM-based chunking.
This takes it even further. You use a powerful LLM to analyze the document structure itself and make these context-aware boundary decisions. The LLM might decide that a specific subheader and the 2 paragraphs after it must stay together, even if it breaks a token limit.
So you get the best possible chunks, but it's expensive and slow to process.
Much slower, much higher cost. You're running every single document through a large model just for preparation.
So there's no single universal winner here, is there? This sounds like one of the biggest tuning knobs in the whole system.
That's the key takeaway. The best strategy depends entirely on your data and what your users are trying to do. PDFs with tables might need page-level chunking. Dense articles benefit from semantic chunking. It all depends on the document type and the query pattern.
Once we have our optimized chunks, we need to translate them into vectors, the language the machine understands, using an embedding model. And this step feels fundamental. Garbage in, garbage out.
It's completely critical. The embedding model translates your text into these high-dimensional vectors that capture semantic relationships. So if two phrases mean the same thing, their vectors should be close together in space.
And if the model doesn't get the nuance of your company's language right,
Your semantic search will fail,
Yeah.
fundamentally. The distance metrics you use, cosine similarity, Euclidean distance, they're only as good as the vectors that the model created in the first place.
which brings us directly to the need for domain specificity.
Yeah.
Why does a huge off-the-shelf model so often fail on proprietary corporate data?
Because general purpose models are trained on the public internet. They aren't optimized for your specific niche terminology. If your documents are full of medical acronyms, internal product IDs, complex financial jargon, the general model might not represent those terms effectively at all,
It just sees them as rare words.
or it breaks them down into meaningless subwords. Either way, you get inaccurate embeddings, and your search quality suffers. If your data is proprietary, your embedding model needs to be proprietary aware.
So the solution is fine-tuning. How big of a difference does it make to train a model on your own in-domain data? Is it worth the effort?
Oh, it's absolutely worth the investment. Fine-tuning actually adjusts the model's internal weights to better represent your unique vocabulary and semantics. This process significantly boosts retrieval accuracy, it enhances the RAG performance, and it directly reduces hallucinations because the retriever is pulling higher quality, more relevant context for the LLM.
And there's an economic advantage here too, right?
A huge one, and it's often overlooked. A smaller, fine-tuned embedding model can sometimes outperform a much larger, more expensive general model in a specific domain.
So better tuning can actually beat sheer size.
It can, which means you improve performance while also reducing your inference cost and latency. It's a clear win for any enterprise deployment where every millisecond and every dollar counts.
That's a huge insight. How do engineers actually test this? How do they evaluate if their fine-tuning was successful?
The most practical way is just direct retrieval performance. You take a curated test set of real-world queries from your domain, and you see if the correct documents and chunks are retrieved. You use metrics like recall at K, where you measure how often the right answer is in the top K results.
Okay, let's move on to storage. RAG has really pushed the vector database from a research niche into a necessary piece of enterprise infrastructure. Why did we need these specialized databases? What was the bottleneck they were solving?
Traditional databases, SQL or NoSQL, are great at exact matches, joins, structured filtering. They're fundamentally bad at semantic similarity search at scale, especially when you're talking about millions or billions of high-dimensional vectors. They just become a massive speed bottleneck.
And the specialized vector databases are built for this specific job.
Exactly. Databases like Pinecone, Milvus, Qdren, Weaviate, they're architected for this workload. They use approximate nearest neighbor algorithms, which are basically a super fast way to navigate the vector space and find good matches without checking every single record. They are essential for production AI.
What are the key features of these modern vector databases that enable the kind of advanced RAG we need in production?
Beyond just storing vectors, there are 3 features that are mandatory. First, metadata filtering. This is crucial. You have to be able to filter search results by structured data like a created date or a priority score or a user category before the search even starts.
So even if the vectors are a perfect match, if the document is confidential and the user doesn't have permission, the database has to filter that result out immediately.
Immediately. It uses that metadata filter. The second key feature is hybrid search support. This means the database can handle both vector or dense search and keyword or sparse search. We'll get into why that's non-negotiable in a minute.
Okay.
And the third, which is paramount for any enterprise system, is data durability and integrity. You can't tolerate data loss. This is why many organizations are actually using existing reliable databases like PostgreSQL with the pgvector extension. It offers ACD compliance and leverages battle-tested reliability.
So it's a trade-off between specialized vector performance and proven data reliability.
It's a choice every engineering team has to make based on their needs.
All right, we've laid the foundation. Now we get to the core challenge.
Mm-hmm.
If vector search is so great at understanding meaning, why is relying on it alone, what's called pure dense retrieval, such a massive liability for factual integrity?
That is the Achilles heel of pure dense retrieval. Vector search is brilliant at semantics, at understanding the meaning of a query. It's great for high-level concepts, but it often struggles, and frankly fails, on exact critical terms.
Like what? Why does it drop the ball on things like rare acronyms or specific product names?
Because when a word like a rare acronym, JCAN, for example, or a unique product ID is embedded, its unique signal can get diluted by the more common words surrounding it in the chunk. So if a user asks for that very specific term, the semantic search might prioritize the overall meaning of the sentence over the precision of that single word.
And retrieve a chunk that's conceptually similar but missing the one critical fact you needed.
Exactly.
So hybrid search is the architectural solution. It's about getting the best of both worlds.
That is precisely right. Hybrid search is the necessary combination of dense, which is the vector search, and sparse, which is keyword or lexical retrieval. Sparse retrieval, using algorithms like BM25, excels at that exact term matching. It catches the critical acronyms and ideas that dense search can overlook.
It makes the whole system more robust.
Much more robust. It captures both the semantic meaning and the lexical, factual precision at the same time.
We've got a great comparison example from the sources about the Strait of Hormuz. Walk us through how semantic search versus hybrid search handled that query. The difference is really telling.
It's a perfect example. When asked a complex question about U.S. foreign policy regarding the Strait of Hormuz, the pure semantic search gave a very generalized answer. It talked about how the U.S. maintains alliances to protect freedom of navigation in the Indo-Pacific. It was suggestive, conceptually correct, but it lacked hard facts.
And what did the hybrid search deliver?
The hybrid search, because it combines semantics with keyword precision, gave a specific, detailed, and geopolitically grounded answer. It explicitly stated that the strategy emphasizes ensuring freedom of navigation through the Strait of Hormuz, noting its specific location in the Middle East and its crucial role in the world's oil supply.
A much more comprehensive and factually precise answer.
Night and day. It proves why you need hybrid for specific entities where exact term matching is critical.
That level of accuracy is non-negotiable for enterprise use. But let's be honest with the listener. Running two search algorithms in parallel has to add complexity and cost, right?
It does. That's a cost you have to acknowledge. It increases latency and computational expense compared to a single search. But the consensus in the field is clear. For production RAG systems in high-stakes environments, the accuracy and robustness gains overwhelmingly outweigh that performance trade-off. It's a necessary tax you pay for verifiable truth.
Okay, so if hybrid search is running two parallel searches, you need an intelligent way to combine the results from both into a single ranked list. And that's where Reciprocal Rank Fusion, or RRF, comes in. It's the fusion engine.
RRF is a cornerstone of this whole process. Imagine you have two expert judges, one who only cares about meaning and one who only cares about keywords. They each give you a ranked list of documents. RRF is the algorithm that intelligently evaluates both of those lists and produces a single, unified result that maximizes relevance.
So it's kind of like a democratic voting system for relevance. It favors documents that score highly with both judges.
That's an excellent analogy. Its main goal is to heavily prioritize documents that appear highly ranked in multiple lists. If the semantic engine thinks a document is rank 1, and the keyword engine also thinks it's strong, say rank 3, that document is probably far more valuable than something that only ranked highly in one of the searches.
Can you break down the RRF process and the formula, especially the role of that constant, K?
Sure. RRF calculates a combined score for each document by summing the reciprocal rank from each list where it appears. The core formula is the sum of 1K plus rank. Rank is just the position of the document in the list, 1, 2, 3, and so on.
So it's reciprocal, meaning rank 1 gets the highest score.
Right. And that constant K, which is usually set to about 60, plays a crucial role. It dampens the influence of documents that appear really low in the rankings. Without K, a document at rank 100 would contribute almost nothing. With K, it gets a small, non-zero score, but the system guarantees that only documents that consistently show up near the top of multiple search methods get a high final score.
So it intelligently broadens the context while keeping irrelevant stuff out.
Precisely. And the final list of chunks sent to the LLM is sorted by that combined RRF score.
Okay, even with these precise retrieval methods, there's still one last bottleneck to deal with.
Okay.
The LLM itself. We know models can suffer from the lost in the middle problem, where important info gets ignored if it's buried in a long context window.
It's a well-documented cognitive bias in these models. If you pass in 20 chunks of context, and the most important fact is buried at chunk number 10, the LLM often gives it less weight than the chunks at the beginning or the very end.
Which is why re-ranking is a non-negotiable step for production systems.
Absolutely. It's a necessary refinement step.
How does re-ranking work? How does it guarantee the LLM sees the best stuff first?
Re-ranking takes the initial large set of retrieved chunks, say the top 50, and then uses a second specialized model, usually a very efficient cross-encoder, to rescore and reorder them. This secondary model does a deep cross-attention check between the query and each chunk, making a highly accurate relevance judgment.
And the goal is to put the absolute most relevant chunk right at the top of the context window.
Exactly. You strategically present the most important information first to maximize its influence on the final answer.
That makes perfect sense. It's an optimization layer after the search. Now let's pivot to techniques that happen before retrieval query expansion and transformation. This is all about making the initial search query more effective.
Yes, these methods try to bridge the semantic gap between a user's short, often vague question and the precise, detailed content you have indexed. One really effective technique is HIDE-E, or hypothetical document embedding.
Tell us about the idea behind HIDE-E. It sounds ingenious.
It is. With HIDE, you prompt the LLM to generate a detailed hypothetical answer to the user's query before you do any retrieval. So if the user asks, "How do I file my Q4 tax return?" the LLM might generate 5 paragraphs describing the forms, the deadlines, common mistakes.
And then you use that long hypothetical answer as the search query, not the user's short question.
That's it. You embed that long text and use it as the query vector.
And why is that a better query vector?
Because the hypothetical document is just semantically much richer and longer, it contains the kind of terminology, context, and language that is far more likely to match what's actually in your vector store. It significantly improves recall.
What's the other major transformation technique, the one involving structured data and filters?
That's natural language filter generation. Often, users want to search based on criteria beyond just meaning like dates, categories, or priority levels. They might ask, "Show me all high-priority tech documents from Q4 2024.
And instead of forcing them to learn a complex query language,
You use an LLM to translate that natural language query into a precise, structured metadata filter. This works because you've defined a clear metadata schema during ingestion. So the LLM can take that query and generate the exact filter expression, like priority 7 A&D category equals tech and needs created date equals 2024-10-01.
which gives you powerful, intuitive searching that combines both semantic and structured criteria.
It's a huge boost for relevance and control over the search results.
We've spent a lot of time talking about how RAG solves the problem of getting verifiable knowledge, the external facts. But let's be clear, LLMs have another major failure mode, one that RAG alone can't completely fix.
That is the essential distinction we have to make between the two types of hallucination. RAG is fantastic at mitigating knowledge-based hallucinations, which happen because of a lack of external facts. But LLMs also suffer from logic-based hallucinations.
Which are flaws in the reasoning process itself.
Exactly. Even if all the facts you provide are 100% correct, the model can still make a mistake in its reasoning or synthesis process.
So if I ask a complex multi-step question, RAG might retrieve all 5 necessary facts perfectly, but the LLM could still stitch them together into a conclusion that's logically wrong.
That's the vulnerability. The chain of thought is flawed. And this is what's driving the move towards agentic RAG, which is really the next necessary step for enterprise AI.
Okay, so how do we define agentic RAG?
It's the tight integration of RAG and this reasoning enhancement into a single dynamic framework. So instead of a rigid one-shot retrieval pipeline, the system operates in an agent loop. It takes a complex goal, it creates a plan, it uses a router to decide the best tool to act. Maybe that's retrieval, maybe it's a calculation. It processes the result, it verifies the step, and then it iterates until it can stop.
So it can break down complex multi-hop questions into a series of smaller, manageable sub-goals.
Exactly. And it routes each of those sub-goals to the optimal tool.
Which brings us to a really powerful form of retrieval for finding those critical connections. Knowledge graph retrieval or graph RAG.
GraphRag is essential for any question that requires stitching facts across different entities and relationships, which is, most business data. Enterprise knowledge is inherently relational, people, projects, products, clients.
It's all connected.
It's all connected. So by structuring your content into a property graph with nodes and edges, GraphRag retrieves the connected context of your data, not just semantically similar text passages.
So it can answer a question like, show me all the projects that person A and person B are both assigned to, and then find the compliance documents related to those projects.
Exactly. It uses a graph query language like Cypher to traverse those relationships. It's uniquely crucial for multi-hop questions where just retrieving isolated chunks of text is not enough. You need to understand the network of information to get the full picture.
The moment we start talking about enterprise knowledge bases, which are full of proprietary IP and sensitive personal data, we run straight into critical governance challenges. What's the state of data in a typical company that makes RAG security so hard?
It's data sprawl. Enterprise knowledge is fragmented across all these siloed, unstructured systems. Word docs, shared drives, emails, PDFs. And historically, this data hasn't been managed with the same rigor as the structured data in a database.
And now RAG introduces this high-volume interaction layer on top of it all.
Right, which demands that robust security and access policies are implemented across the entire workflow, from ingestion to generation.
So what are the mandatory steps to protect the RAG pipeline? Let's start at the beginning. PII mitigation during ingestion.
PII mitigation is absolutely non-negotiable. Sensitive data addresses, social security numbers, account details. It has to be identified and treated, meaning masked, tokenized, or redacted, during ingestion. And this has to happen before it's ever seen by the LLM or turned into an embedding.
But there's a trade-off there, right? If you strip out too much, you could hurt the model's accuracy.
You do. You have to strike a balance between robust privacy controls and preserving just enough semantic context for the model to perform well.
Okay, once that data is vectorized, what about the vector store itself? The embeddings are derived from sensitive data.
They contain the semantic fingerprint of that sensitive data, so the vector store itself has to be hardened. This means the embeddings must be encrypted at rest, typically using robust services like AWS Key Management Service or similar controls. You can't treat these vectors like they're just benign math.
And for highly regulated industries, there's the concept of key sovereignty, or bring your own key. Why is that so critical for compliance?
Key sovereignty is mandatory in these spaces. Organizations have to maintain independent control of their own encryption keys using that BYO strategy. This ensures that the ultimate control over the data remains with the data owner, not the cloud provider or the LLM vendor. It's essential for meeting strict mandates like APA or GDPR.
It proves that only you have the power to decrypt your data.
Exactly.
And finally, we have to make sure that when a user runs a query, they only see results they're authorized to see. This is about integrating with existing IT permissions.
This is handled by access control. The RAG system must implement fine-grained access control, or FGAC, and role-based access control, or RBAC. This is done using that metadata we talked about earlier. Search results are filtered based on the user's specific permissions. If you don't have access to the original document, the system has to prevent that chunk from being retrieved or leaked in the final response.
Okay, we've built this incredibly complex, robust, secure architecture.
Yeah.
But how do we know it's actually working? How do we know it's producing trustworthy results? We need rigorous, repeatable evaluation. You can't manage what you don't measure.
Evaluation is the absolute prerequisite for continuous improvement. Relying on subjective human feedback is just too slow and inconsistent. The industry has really started to converge on a standard framework for this called RAGAS.
What does RAGAS measure, and why is it better than just looking at the final answer?
RAGAS provides a set of measurable metrics that test the entire system end to end. It uses an automated comparison against a ground truth data set of questions, ideal answers, and the relevant context. Its core metrics are all about verifying the model's honesty.
Honesty meaning?
Meaning groundedness and faithfulness. Groundedness ensures that the response is based only on the provided context, the chunks that the RAG system retrieved. Faithfulness checks that the claims in the answer are entirely verifiable by that context. If the system makes something up that wasn't in the chunks, it fails groundedness. If it misinterprets a fact from a chunk, it fails faithfulness.
So these metrics directly quantify the reduction of hallucination risk.
They do.
And what about the quality of the retrieval phase itself?
That's covered by context adherence and retrieval quality. This evaluates how relevant and, crucially, how sufficient the retrieved information was to support the answer. If the retriever missed a critical chunk needed to answer the question fully, your context retrieval quality score drops, which tells you there might be an issue with your chunking strategy or your embedding model.
And lastly, what other end-to-end metrics should developers be tracking for overall system performance?
Beyond accuracy, you have to track operational metrics. Latency is paramount. A slow RAG system is a useless RAG system. For user experience, you track helpfulness, how well the response actually helps the user, and things like conciseness and consistency. Combining all of these ensures your pipeline is performing both accurately and efficiently.
This deep dive has really underscored that RAG is so much more than just a simple wrapper around an LLM. It's a complex, multi-layered enterprise architecture, and we saw hard evidence that when it's done right, RAG transforms AI potential into quantifiable value, with documented cases showing a 333% ROI and payback in less than 6 months.
Which is a stunning rate of return. And that success, as we've detailed, comes down to mastering complexity. The three core architectural necessities for production are, first, implementing hybrid retrieval with RRF to ensure accuracy. Second, optimizing with domain-specific embeddings to really understand your business's unique language. And third, enforcing robust end-to-end governance.
For those out there building these complex systems right now, what frameworks are leading the way in helping developers manage all this complexity?
The two leading frameworks are really LlamaIndex and LangChain, which is often paired now with LangGraph. LlamaIndex is generally preferred for data-intensive RAG workflows. It excels at ingestion, indexing, and complex querying structures like GraphRag. LangChain and LangGraph are better positioned for those complex agentic workflows, focusing on orchestrating the planning, routing, and acting across multiple tools.
So agentic systems are the future here.
They're the inevitable future for complex, multi-step enterprise needs. It's a shift from rigid pipelines to dynamic multi-tool agents.
All right, a final provocative thought for you, the listener. We saw fascinating evidence that fine-tuning a smaller embedding model can sometimes drastically outperform a much larger general-purpose one, especially on your own proprietary data. But this level of RAG architecture building knowledge graphs, fine-tuning embeddings, enforcing key sovereignty, it raises a deeper question. Are we witnessing the gradual end of our reliance on the giant, foundational, generalized LLMs? Think about the strategic power you gain when your entire knowledge system is owned, tuned, and architected, specifically for your business and your data, not for the public internet. The crucial question isn't whether to use RAG anymore, that's settled. The question is where to apply your maximum optimization effort. Start measuring today with frameworks like RAGAS, and focus your engineering budget where the data tells you your bottleneck really lies.